Hello everyone, here is question number 1 of WAEC 2025 further mathematics examination. Remember I told you that the A part of question number 1 has no solution. What I mean, it has no inverse because we are asked to find the inverse. The question reads, a binary operation, you can see the operation here, is defined on a set of real numbers by x asterisk y equal to 2x plus 2y minus xy divided by 5. Then we are asked to find the inverse of x. X here stands for any number you pick at random within the set. So we are asked to find the inverse of a number within the set under that operation. Unlike the basic operations, we have plus, minus, times, division, right? When you're talking about binary operation, it is not unique. It must always be defined. This is why it is defined like this. You may see another question where the same binary operation will be defined differently. And the B part, we ask to find the truth set when m asterisk 7 is equal to negative 2 asterisk m. We are looking for the inverse, but you cannot find the inverse until you know what an identity means. So A part, we know that any number you pick, you connect it with this operation, by its inverse, you're going to get an identity. Yes, and taking that number, you relate it with that operation, with the identity, it will give you back the number. So we can use this particular equation or statement to find E, then we bring it back here in order to find the inverse. But once we cannot find the identity, then it implies that the inverse does not exist. So what is the definition? The definition says you should take the first one, you multiply by 2. So this is 2x plus what? 2e, according to the statement. The minus 2e again. xe divided by 5. This will remain the same thing. It will give you that number you have taken within the set. So let's simplify this. I think we can even bring this one backward. If x comes here, it becomes negative. That is 2x minus x will give us x. And x, I can bring this one that contains x. xe divided by 5. Then we still have 2e here. I can see x in common here, so I can factor out x. Inside we have 1 minus x is already outside. We have e divided by 5 here, right? Then plus 2e equal to 0. But you can see that our identity is dependent on x, which we don't want. But this can only be true because you can see something plus something equal to 0, right? We know that this x is a number which we have taken from the set. So therefore, for this to be 0, even if this is 0, this cannot be 0. So for this statement to be true, for every number you pick within the set, then the coefficient of x must be 0. So what is the coefficient of x? You can see 1 minus e over 5 must be 0. 1 minus e divided by 5 must be 0. And this can only be 0 if e is 5. Yeah, because 5 divided by 5 will make it 1, and 1 minus 1 is 0. And also the constant must be 0, because it has to be 0 plus 0 in order to get 0, right? So 2e, yeah, 2e here, 2e must be 0. But we have seen that e here is 5. So 2 times 5 is 10, and 10 can never be 0. Or you can break it from here and say that e equal to 0, right? By dividing both sides by the coefficient of e, which is 2. So how can you have two identities? No set can have two identities because this identity is true for all the members within that set. So we cannot have two identities. And hence, I don't want to write everything, but I'm explaining. Since we have two identities, which is not true, that it implies that the inverse does not exist. The inverse does not exist. And let me show you that it does not exist. You see, we have gotten two identities, right? So let's assume we would like to solve for identity in terms of x. How can we do? I think from here, where is that? We can make E the subject. I think from here, let me clean all of this. I want to prove it for you again. If you take 2x to the other side, it becomes negative, right? Negative 2x, and x minus 2x will be negative x. So, and here we can factor out E. Inside we have 2 minus x divided by 5, right? This is equal to negative x because x minus 2x is negative x. So let's simplify this. This is the same thing as 10 minus x. 10 minus x divided by 5, right? 10 minus x divided by 5 equal to negative x. Let's come here. If you multiply both sides by the reciprocal of this, you have E to be negative 5x divided by 10 minus x. 10 minus x. Assuming this is our identity in terms of x, then we can bring it back. We know that by relating anything with the identity will still be that thing. So let us relate them. We know that the identity is that. But from here you can stop. Bringing back identity here will not solve the issue. Remember, this is true for all elements within the set. This is a rational function. 10 minus x. What if x is 10? Because 10 must be a member. We are talking about real numbers. 10 is also a real number, right? 10 minus 10 will give you 0. And in mathematics, we don't divide by 0. From here, you can even conclude that this statement is not true because x can be 10. 10 is also a real number. You can see that from the set of real numbers. Therefore, the first question here, 1a, has no solution. But we can manage to solve the second one, despite the fact that we know this has no identity, has no inverse. So let's solve the second problem. The second problem, we're only going to apply the definition here. M asterisk m will be what? 2m plus 2 times 7. That is 2m plus 14. Then minus this time base, that is m times 7, that is 7m divided by 5. This is equal to, you do the same thing here. 2 times negative 2 will give us negative 4. Then plus 2m. Then minus the first time the second, right? This time this, but this will become plus because of the other minus here. That is 2m divided by 5. I don't like seeing fractions, so let us multiply by 5. This times 5 is 10m. 5 times 4 is 20. 5 times 1 is 5 plus this is 70, right? Minus 7m, because 5 will cancel. This is equal to 5 times this is negative 20 plus 5, this is 10m plus 2m. So no more fraction. So let us collect the like terms, bring all the variables to the left. We have 10m here minus 7m. This together will give us 12. It becomes negative 12 here. This is equal to, we have negative 20, right? Then this will cross over to become negative 70. Let's see what happened here. 10 minus 7 is 3. And 3 minus this will be negative 9. This is negative 9m equal to, this is 90, right? Negative 90. If you divide both sides by negative 9m will be equal to 10. But do not write m equal to 10. Remember, we are talking about set. Therefore, the set values of m that can satisfy this is what? This implies what? 10 inside a curly bracket. Make sure you write that 10 inside a curly bracket. So this is the solution for the second problem. But for the first one, the inverse does not exist. Bye-bye.